And this is possibly the way they are causing the sun to go dark for certain periods of time. When they make contact with the sun, they draw on the sun's outer layer of electrons. When that happens, the sun's driving electric potential drops, and because the sun's an electrical object and emitting light, due to that electrical potential, it stops emitting light, it goes dark. And the previous article I have written was about that, about the fact that the sun goes dark and what are the implications. Now, comet tails always point away from the sun, and according to James McCanney, are very narrow when the comet is far from the sun, become very wide when the comet approaches perihelion position. So this is the reason why it looks like there are more than two tails. It develops, it's very wide, it's possibly coming from two different nebula cloud regions, and they become wide like this. And then the electrons come in and start interacting. Some of the electrons will go this way, some of the electrons will go that way, as they are pulled in towards the positive ions. So this is an illustration of what these comet tails will look like when a comet approaches perihelion. This is not a comet, but it is drawing current from the solar capacitor, like a comet would, because it has developed some a weak, although some outer negative layer. So as you can see, these tails point outwards from the sun, somewhat like these ones here. So this is possibly this one points further up, so the object may be here somewhere, either slightly behind the sun or right next to the sun, as far as its perihelion position is. So this object must be very close to the sun at this moment in time, and this means that we can actually do a direct size comparison with the sun, and we can see therefore that it's likely to actually be 2.5 times the size of the sun, at least the comet is. And the object itself, indicated by this dark circle, is about the same size as the sun. Now, the object of interest, therefore, as I said, must be very close to the sun, and therefore it's about the same size as the sun. And these objects are likely to be very close to the sun as well. As we know, stellar cores come very close to the sun. They come so close to the sun that they go into the sun's corona and make this kind of connection. This one here is about half the size of Jupiter, but we have much larger ones that have come in. And these objects interact gravitationally with the sun in a very, very weak manner. So their gravitational attraction is very weak. They come to the sun through the electric interaction. They are electrostatically attracted to the sun. The gravitational interaction is very weak. Now, so one of these objects in the 2009 is brighter than the one in the 2018. As you can see, this one's brighter, but the others are fainter, suggesting that the stellar cores associated with these fainter tracks were more depleted in electrons than the stellar core producing the brighter track. Now, stellar cores are explained in Article 184, entitled Stellar Core Evolution, as arriving in the solar system so depleted in electrons that they have a neutral rather than a negative outer layer. And this is a diagram from that article that illustrates the evolution of a star into a dead star stellar core. And you start out with a star that has a full amount of gravitational energy. It's able to generate a lot of gravitational energy, and this is done through decay of unstable nuclei or fission in the core. And it has a full complement of electrons, although stars will continuously lose electrons. They will move out with some of the ions that move to the sun's outer layer, and from there, because they are weakly attracted, will leave the solar system and move on into the galactic or intergalactic space, or interplanetary space first, and then into interstellar space. So as the years pass, the star will lose the ability to generate as much gravitational energy in the core, so the electric potential between the core and the outer negative layer decreases, and eventually a point is reached when the star is no longer able to emit light. And because the gravitational attraction decreases because of the loss in gravitational energy, the star will also increase in size. And at the same time, the star's effective mass, that is its ability to draw other objects gravitationally towards itself, will decrease. So it will grow in size and seem to have less effective mass. At the same time, it will continue to lose electrons. Eventually, it reaches a point where it hardly generates any gravitational energy. It will still most likely maintain a positive core for a while, but it will be completely depleted in electrons. And as the potential decreases, the electrons will start moving inwards, so it becomes more neutral as well. And eventually the outer layer becomes completely neutral. There are no negative electrons there. So at this stage, it has become a stellar core. But it's a positive object, and it will be attracted to the negative outer layer of other stars or the galactic nucleus. These dead stars are actually supposed to move back towards the galactic nucleus for reabsorption, and obviously a system of these objects have encountered our sun and were attracted to the sun, to its negative outer layer, since it still had a full complement of electrons there, and they've come in, they've moved into the sun's corona and started absorbing electrons and gravitational energy from the sun. So as we can see, this is illustrated here. Our stellar core is a positive ion, or a positive super ion. It's attracted to the sun's negative outer layer. So it's the electrostatic attraction that brings them to the sun. The gravitational attraction, there is still some, but it's very weak. So in the initial state of electron depletion, stellar cores will not draw a current from the solar capacitor. But once they make contact with the sun's corona, they will draw electrons from the sun and start replenishing their supply of electrons, whilst causing the sun to become depleted. Initially, the electrons they will draw will move below the surface toward the inner core, but eventually, as the object gains gravitational energy by drawing matter from the sun containing protons, it will be able to start forming a negative outer layer of electrons. Once this negative outer layer is in place, the stellar core will be able to draw current from the solar capacitor and will thus produce comets and comet-like tails, as seen in the image in figure 1. Now, the fact that it produces a dark tail indicates that it is still absorbing electrons, and that the process of absorbing enough electrons may take a very long time. In addition, since they will most likely draw electrons from each other as well as the sun, it is possible this process will never be complete, as new objects seem to continue arriving in the solar system, and they will thus continue to draw electrons from the sun indefinitely until the sun has no more to give. Now, comets would not produce a dark trail because they arrive in the solar system with no electron depletion. In other words, there are enough electrons in the outer layer to cancel the positive charges on the inside, which is analogous to them being a neutral atom, which has enough electrons in its outer shells to cancel the positive charge inside the nucleus due to the protons present there. And this is illustrated here for a lithium atom. A neutral lithium atom has 4 protons in the nucleus and 3 protons in the nucleus and 3 electrons in the outer shell. So it's neutral because there are as many negative charges as positive charges. But if it this lithium atom was to lose one of its electrons, then it will become a positive ion, because then it has one more positive charge than negative charges. And the way this would occur is if it absorbs a photon, and a photon is gravitational energy, and the moment this electron absorbs a photon, then the repelling gravitational interaction between the proton and the electron, which is opposite to the electrostatic interactions I explained in previous articles on gravity, then this repelling force increases, and when it increases, the electron either will move away from the nucleus, it will move to a higher orbit, or it will exit the atom completely. And when it does, this atom becomes a positive ion. So it's actually photons or gravitational energy that causes electrons to move away from the nucleus of an atom, and to also move away from the positive core of a celestial body and move to the outer layer. And this is why all objects then have outer negative layers. It is actually because of the gravitational interaction and the fact that there is gravitational energy being generated in the core. So in conclusion, the object seen in a LASCO C3 image appears to be a stellar core which, although still depleted in electrons, has been in the solar system long enough to have developed an outer layer of electrons, so that it is now able to draw a current within the solar capacitor and thus produce comet characteristics, namely a coma and tails. The dark track indicates that the stellar core is absorbing electrons coming from the sun's corona and are still in a depleted state. In addition, the object must be following an elliptical orbit, as objects in circular orbits will not draw current from the solar capacitor. And these are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.